Carla Maia. I'm an assistant researcher at the Institute of Hygiene and Tropical Medicine, Universidade Nova de Lisboa, Lisbon, Portugal. I work on vector-borne zoonotic parasitic disease, especially on leishmaniasis. This presentation is about the storage of phlebotomine sandflies for isolation and molecular detection of pathogens. The aim of this presentation is to learn how to store phlebotomine sandflies for the isolation and molecular detection of Leishmania, Trypanosoma and virosis. Depending on the collection method, phlebotomine sandflies can be caught alive or dead. Please see the presentation about the different methods for collecting phlebotomine sandflies. Parasites can be detected in the midgut of live females immediately processed. After dissection of the midgut, parasites can be microscopically visualized and then inoculated in culture medium such as NNN medium or Schneider medium supplemented with fetal calf serum. Please see the presentation on how to perform midgut dissection and how to culture parasites. Be aware that this procedure is laborious, requires high level of expertise and is prone to bacterial contamination. Leishmania and Trypanosoma DNA can also be detected from phlebotomine sandfly females kept alive, stored at -80 degrees in RNA later or preserved in 70% ethanol. Please see presentations of how to prepare phlebotomine sandfly females collected from CDC and sticky traps for molecular detection of protozoa DNA. Leishmania and Trypanosoma DNA can be extracted using commercial kits or trizol or phenol chlorophyll methods. And the DNA can then be detected by different molecular techniques such as PCR or real-time PCR. Please see presentation of how to extract DNA from phlebotomine sandfly females. This molecular approach can also be used on blood-fed females to identify the blood meal source. Please see presentation about the molecular identification of blood meal sources. Phlebotomine sandfly females and males collected alive and immediately processed or kept dry at -18 can be used for virus isolation by cultivating their supernatant of their macerators in, for instance, Vero cells. Virus can also be detected by molecular techniques after RNA extraction and reverse transcription to cDNA. Those specimens collected alive and kept in RNA later at -20 degrees can be used for virus detection by molecular techniques. Be aware that specimens from the same trap, from the same species and same gender are normally pooled before being processed. Apart from pathogen detection, it is important from the epidemiological point of view to identify from which phlebotomine sandfly species the pathogen has been isolated or molecularly detected. Please see the presentation of how to identify phlebotomine sandflies using morphological, molecular, and multi-mass spectrometry tools. In this flowchart, it is going to be presented how to identify phlebotomine sandfly species and the pathogens they can harbor using different methodology. For example, alive specimens from both genders collected with CDC traps and immediately processed can be used for molecular or morphological identification of sandfly species. They can also be used for isolation and molecular detection of virus and for the mass spectrum protein profile. In addition, females can also be used for the Leishmania and Trypanosoma isolation or for the molecular detection of protozoa DNA. The same line of reason can be used for specimens collected alive and preserved dry at -80 degrees, preserved in RNA later, preserved at -20 degrees, those preserved in 70% alcohol, and in dead specimens collected from CDC. A similar flowchart can be applied for specimens collected from sticky traps and from those collected with the mouth mechanical aspirators from resting sites. As a take-home message, phlebotomine sandfly females caught alive and immediately processed can be used for the isolation and or molecular detection of protozoa and viruses. Those kept dry at -80 can be used for the isolation of virus and molecular detection of protozoa and virus, while those kept in RNA-later at -20 degrees can only be used for the molecular detection of pathogens. Regarding phlebotomines and fly, females caught alive or dead and preserved in 70% alcohol, they can only be used for the molecular detection of protozoa. Finally, phlebotomines and fly males caught alive and immediately processed can be used for the isolation and or molecular detection of virus, while males caught alive and kept dry at -80 degrees or in RNA later at -20 degrees can be used for the molecular detection of viruses. Thank you very much for your attention.